My name is Ed Pinto. I'm a PM working on the WCF and WF team, the team that brings you those two technologies. I'm hoping that you're here today to hear about how combining those two technologies makes your life as a service developer a little better, a little easier, a little sweeter. This is a 300-level talk. The expectation is you are familiar with WCF. You've written some services, you've written some clients, you know what an endpoint is, service contract. We're also expecting you to be a little familiar with WF. Quick show of hands. How many of you are using WF today? Great. How many of that crowd is using 3.5 and writing workflow services? Okay. So for those of you who aren't familiar with WF and maybe didn't get a chance to go to Kenny's talk, we are going to spend a couple of slides just going over the basics of 4.0 to get you up to speed, to give you context on the rest of the talk. So this is not a WF fundamentals or a WCF basics talk, though. This is really a talk about the increasing percentage of services out there that we write that coordinate work, and how applying WF to the messaging space increases your productivity and increases the quality of the services that you write. The way that we're going to do that is we're going to talk about some challenges and some trade-offs that we see people making in the services they write today. And we're going to do that little tour of WF 4.0 basics using a couple of slides that you may have seen in Kenny's talk. And then we're going to dive in and talk about how combining WCF and WF pushes complex coordination code into the framework, specifically around coordinating asynchronous work, error handling scenarios, and in coordinating messages with app state using correlation. We're going to pop up and we're going to talk about hosting and monitoring and how using WF really increases the transparency of the services that you write through tracking. Finally, of course, we've made a number of improvements to WCF independent of WF, and so we're going to go through a quick list of those at the end. But first, let's start off talking about these trade-offs. In the apps that we write today, more and more work is being done piecemeal than ever. Our services may get that work done by calling a database, calling another service, but the code that we write to coordinate that work is complex. Consider a service that manages some state over time, right? Typically, we put some state in a database to make it queryable. In order to be efficient with server resources, we try and keep that state out of memory. So we see this pattern where we've got this operation with an argument on this operation. We use it to go and look up some state in a database, evaluate whether this message is appropriate given the state in the database. We apply the logic of the service. We stick that state back in the database, making sure that nobody else has changed it while we were looking at it. So some of the logic of our service is focused on the doing, right? The business, or whatever kind of logic your service uses. But a lot of it is focused on coordinating that message with that app state. So services call databases to get work done. Services call services to get work done. Calling databases, calling services. These things involve I/O, and as you know, I/O, right, has perf implications. Now you can go async in order to deal with those perf implications, but writing async code is hard. It's complex, right? So you've got this trade-off to make. You can have a simple authoring model, the blocking call, that doesn't perform, or you can bite off that complexity and bury the logic of your service in an async result. You can have perf or simple to maintain code, but not both. Another area where we write a lot of coordination code is in rainy day scenarios, right? Exceptions are great, but if you just bit off that async bit, your exception handling just got crazy. You may have an exception from your begin call, from your end call. You might have to marshal that exception to a different thread. Another tool that we use to coordinate rainy day scenarios is transactions, right? But as work gets more and more distributed, as work takes longer to do, as work crosses trust boundaries, transactions apply less and less. You're not going to be able to hold a lock on somebody else's resource. You're not going to be able to hold a lock for a really long time. And so we end up coordinating messages that facilitate cancellation, messages that facilitate compensation on other services, on our own service contracts. Finally, as our applications and services get more and more distributed, the management and the diagnosis and the monitoring of these services gets more challenging. Now, WCF comes with some great facilities for watching a message go through the message stack, but if you don't invest in instrumenting your code, right, the trail goes cold. It's hard to diagnose why a message isn't being sent, a message isn't being received. Increasingly, our IT pros are saying, tell me about what's going on in your service. It's great to have metadata and describe what your service does, but I want to see what's going on while this thing is executing. So these are some of today's challenges that we'll be talking about throughout the talk. We're going to see how WF and WCF compose to give you increased productivity, increased quality of service, pushing coordination code into the platform while increasing the transparency of your services. But before we do that, let's just do a quick tour of WF. WF is just another way to write programs. The spirit of WF is really coordinating work with as little fuss as possible. It's made up of 3 parts. Activities are the core abstraction for behavior, the unit of work in workflow. Activities are inherently resumable, so they lie around a lot, then something pokes them, they go and do a bunch of work, and then they go back to lying around where they complete. The runtime is the thing that executes activities. Okay, so the host possibilities for the runtime that's going to execute those activities include IIS WAS with some app server extensions called Dublin that we're going to talk about later on in the talk. Mustafa Ahmed is going to talk about hosting the WF runtime tomorrow in the cloud using Microsoft.NET Workflow Service. And finally, of course, you can host the runtime yourself using your own host, your own exe. The third part of WF is the tooling. Visual Studio gives you the ability to design workflow programs, to debug workflow programs. The framework for designers is extensible. You can write your own framework, your own designers, and you can also rehost the designer in programs that are not Visual Studio. Matt Winkler is going to give a talk on building custom activities and writing designers for them later on today. So I want to emphasize just a couple of things that we're going to be seeing in the demos today that are new in 4.0. Activities as the primitive abstraction for behavior. That's common across the 3.0, 3.5, and 4.0 model. But in 4.0, we've written a new activity model to work on a new activity runtime where we can flow data into activities using arguments. This is different than dependency properties. Arguments define data flow into activities. They have direction. They can be in or out or in-out. Arguments are fixed at activity definition time, so they provide a kind of signature for activities. Like 3.0 and 3.5, activities are composable with other activities. A parent can have children. You can see this sequence here that's got a generate order and a send message. Sequence is kind of like curly braces in C#. Things are going to execute in order. Given the extensibility of the activity model and this composition, you can write control flows that don't show up in languages that you're commonly familiar with. In 4.0, we ship flowchart, as well as state machine and other control flow activities. So hopefully you can see then, one more thing that I wanted to mention was, obviously, if we're going to share data between activities, we need to have some way to represent storage. Again, new in 4.0, we've got variables to do this. We declare variables, and activities can bind their arguments to variables that are in scope. So when an activity is looking up the parent chain, those are the variables that it's going to be able to see. Hopefully you can see that these constructs, arguments, variables, and also the composition of larger chunks of behavior using smaller chunks of behavior, these are common constructs, so you should be able to make a lot of relationships in your mind between workflow and writing programs like you do today. Again, for those that are familiar with 3.5, the way that we write workflow services in the 4.0 timeframe is quite similar. We extend the activity library with some activities for sending and receiving messages. We host those in a workflow service host. Workflow service host augments the WCF base hosting infrastructure. It's the thing that's going to dispatch messages to our workflow services. It's the thing that's going to manage workflow instance lifetimes. When a service is waiting for input, the workflow service host can unload a workflow. When that input arrives, workflow service host is going to load that workflow back up and resume its execution, dispatching that message. It's going to use persistence extensions in order to facilitate that unloading and reloading. The execution of your workflows can be captured by the tracking behavior that comes in 4.0. And new in 4.0, on top of these features, we've exposed a management endpoint from workflow service host. And on that management endpoint, we can send command and control messages. So you can cancel a workflow, you can terminate a workflow, you can suspend it. Okay, so enough of this setting the table, enough of this context giving. Let's look at some real programs and problems that we can address by applying WF to the messaging space. First, let's look at how WF helps writing those services that do asynchronous work. Okay? Services that call databases, services that call other services. As I mentioned at the outset, you've got a trade-off to make. You've got a decision to make. You can have a simple authoring model that doesn't perform that well, or you can bite off a bunch of complexity, bury the logic of your service in an async result, and get the perf that you want, but sacrificing the maintainability of your code. In this first example, you can see that I'm using this blocking I/O call, which performs poorly, but keeps the service simple to author, simple to maintain. In the second example, I'm getting the performance that I want, but I've buried the logic of my service in a bunch of complex async coordination code. Another observation that I'd make about this service, about using the blocking I/O approach, is that the scenarios that are available to me are limited, right? Given that these calls are blocking, I can't make them in parallel, unless, again, I bite off the complexity of using an async result and coordinating that work with an even bigger async result, using some wait handles and stuff like that. And so, ideally, what we'd like to allow you to do is focus on the logic of your service while giving you the perf characteristics that you really want. And workflow is going to give you that performance. It's going to give you the performance of async while allowing you to express your logic simply and succinctly. If you went to Kenny's talk, you heard about how the workflow runtime has gotten a significant overhaul, dramatic increases in performance, a new activity model that allows you to define your programs in a completely declarative fashion, finer grain instance control and predictability of execution. Another thing that we've done in the 4.0 runtime is we've enabled activities to coordinate async work with that runtime. An activity can say, hey, I'm about to go do something asynchronously, get off of the scheduler thread, go and do that async work. When that async work completes, say back to the runtime, I'm done, could you please call me again on the scheduler thread? And then when the runtime does that, the activity can marshal the results of its async work back into the workflow system. So workflow is a natural way to express the coordination of asynchronous work. Here I'm just composing an activity, get media. Get media is an example of a client operation. I've composed it into a sequence along with some other activities. I get true parallelism in 4.0. When I've got these two client operations in a parallel, they both get off of the scheduler thread. As soon as they start executing, they go and do their work asynchronously. So you've got multiple threads going on, multiple threads of work going on at the same time. So you can see now how 4.0 pushes the complexity of this coordination code into the runtime while giving you increased simplicity and maintainability of your services, and expanding the scenarios that you can achieve, right? Another observation relative to the ability to write new control flows or use different control flows in the system, right? I can use flowchart to express my work. I can use state machine to express my work. You can write your own custom control flows. So the scenarios that you're able to accomplish have expanded while you're able to focus succinctly on the logic of your service. Enough talking about it. Let's apply this. So here's my scenario. I've got a picture service. It takes a name, and it gives me back a picture. Unlike Dawn, I am not tired of the picture service scenario. So this picture has some metadata on it, and it's got the picture represented in XAML markup. It's just a string of XAML. The way that it gets its work done is it calls two back-end services in parallel. The picture info service is going to give us that metadata. The media service is going to give us that picture. It's going to coalesce these results and send it back to the client. All of these calls are being made over HTTP using request response. So now I'm going to switch over to the demo, see how this works. So my back-end services, I've got hosted, self-hosted for demo purposes. My picture service is hosted in IIS. And when I call this picture service, I'm going to just pass the name of a picture that I want. The picture service is going to make those calls in parallel to the back end, and I'm going to get the result and display it to you here. Right? Great. So how was this service written? Here we're looking at the 4.0 designer. 4.0 designer, we've got, let me just give you a quick tour if you haven't seen it before. Sorry about that. So the 4.0 designer has got a bunch of activities in it. These are the activities for which we have designers already in the box. This box is going to get more full as we get closer to ship. We drag those activities out onto the canvas that you're seeing here. Down here we've got some pane for variables. As I was mentioning earlier, this pane is going to show us variables that are in scope, so variables that are visible from the child to the parent. And you'll see this populated with different variables as we go through the construction of this service. And of course, we're using the property grid as the thing that we use to configure our activities. So here we bind operations, we set parameters, and so forth on our activities using the property grid. Okay, so toolbox, property grid, variables, canvas. Let's look at how this particular service was built. What you see here is a service operation activity. I've named it getPicture. It's using the contract for getPicture that I've defined with the contract builder tool. If we look at the contract for getPicture, you can see that it takes a name of type string, and it's going to have a result of type PDC picture. I can blow that out for you. Here we are. PDC picture is the thing that we're returning as the result for this getPicture operation. When we look at the implementation of our service operation, it's in this after receiving message. After receiving message is just an activity-based callback where we flow the state of the service operation to the implementation. So by selecting the sequence in here and then looking at the variables that are available, you can see that I've got a name and a result variable to look at and bind to from within the implementation. Names coming in, results going out. If we dig into the implementation of this service, you can see that I've implemented it using a parallel activity. Parallel is just going to schedule branches in parallel. I've got two client operations that I'm using to call the back-end services, get picture info and get media. I'm using basic HTTP binding on these client operations, and I've hard-coded the address here to the back end of these services. This is just an argument. Again, arguments represent the flow of data into an activity, so I could have bound this to something more dynamic. I can also use config in order to set up the arguments on a client operation to the back end. So let's look at how one of these things is configured. If we look at the call to get picture info, you can see that the arguments for this client operation are a name going in, right, of type string, and the result that we're going to get is this picture info object. And so what I've done is I've bound the name from the service operation, and I've declared a variable named picture info where I'm going to put the result of this call. So if we go and we look at the variables over here, you can see that I've got this picture info variable, and this is the thing that I'm populating with the result of the client operation call. If we go and look at get media, something similar, flowing the name back, getting the result, which is just a string, and sticking it in a variable of type string named XAML. Okay? After the parallel completes, I'm just using an assign activity to coalesce these two results. So if we look at the expression in the assign here, you'll see that I'm just creating a new picture using the variables that I've stored the results of those client operations in. Okay? So the client operations are the real workhorses here. They're the things that have been implemented to open the channel asynchronously, send the message asynchronously, close the channel asynchronously if need be, and coordinate all of that async work with the runtime using that coordination mechanism that I mentioned on the previous slide. But that's not our focus here, right? What we focus on is, hey, I needed to be able to call a couple of back-end services in parallel and coalesce the results from those services into a picture that I'm sending back to the caller. For those of you who previously thought of workflow as something heavyweight, something that requires persistence, something that you use for long-running services, I'd point out there's no persistence involved in this service, right? All I needed was a way to express the logic of my service without clouding it with a bunch of coordination code. Workflow gave me that, okay? Cool. So let's take a look at another scenario where we get a lot of coordination code. I'm just going to switch to an example that deals with some of the exceptions that may come out of the back-end services. Here you can see I've got this same service operation, and I've implemented it using try, catch, finally. The media service, as it turns out, is going to send a fault back when I ask for a picture that doesn't exist in that service. And so I've put my client operation into the try block. Cool. Calling get media, just like I did before. And in my fault exception, instead of letting the exception go back to the client, I'm capturing it, and I'm going to put some stock XAML in, just a text block that says this image isn't available. Again, if you think about how this would work using asynchronous code, it would be pretty complex, right? You'd have to handle the possibility of exceptions on the begin, on the end, and yet here we're able to succinctly express how we want this exception to be handled, right? If I make this call, I ask for something that doesn't exist, we get this image not available. Wonderful. So let me just get rid of some of this stuff for the next demo. And switch over here. Cool. So when I'm working with error handling scenarios, I'm able to co-locate the activities that do the work with the variables that they're operating on with the activities that handle exceptions, right? But exceptions aren't the only scenario where we need to do this kind of work coordination. From the previous versions, we've gotten the requests from customers saying, please allow me to flow transactions in to my workflows. In 4.0, we're able to flow transactions into the workflow runtime. Again, this follows that theme of coordinating work, pushing coordination of work into the framework while simplifying the way that you express your services, express your programs. In this example, I've got this flow-in transaction scope activity that has a receive message in it. The way that this activity can be configured, we can configure it to abort the workflow when that transaction is rolled back, which is pretty cool because what that means is the state of the workflow is going to be returned to the place that it was before the transaction started. You're not going to find this activity in the bits that you have today, but it will be there in the RTM time frame. In real-world apps, as I mentioned earlier, we can't always do our atomic state changes using transactions. So we often need to use some kind of non-transactional coordination protocol in order to cancel outstanding work, in order to undo something that's been done or completed. Once again, in fitting with the theme of pushing that coordination work to the platform, Workflow provides a programming model for compensation that allows you to focus on the logic of your service while Workflow handles compensation, cancellation signals, and the management of your state. Here I've got a compensable activity. Work that may need to be compensated is co-located with the variables that it operates on and the logic that performs the compensation. From here, it's the framework's responsibility to listen for those compensation or cancellation signals, manage the lifetime of the state associated with this work, invoke the compensation logic if necessary, clean up that state whenever that compensation episode is complete. So the lifetime of the state is managed on your behalf, right? The compensation logic is co-located with the logic that actually acts or performs the work that you want. And the framework is responsible for the compensation and cancellation protocol. Again, for rainy day scenarios, we're pushing the coordination of work into the platform while allowing you to express the logic of your services much more succinctly and clearly. Cool. So we're getting these benefits for async. We're getting these benefits for error handling. What about those other scenarios that require coordination? What about those scenarios where we've got to coordinate messages with app state? We'll refer to this as correlation. There are a lot of different correlation scenarios that we are involved in, a lot of different correlation mechanisms that we use. What I'd like to do now is just go through an example to get all of us on the same page, go through some example that we can use to give us a language to talk about correlation. So here we've got an application. It starts off with some state, job 1, 2, 3, sticks that state in the application store, And then in order to get its work done, it's going to go and send some message out, submit task to some task service. Importantly, it's going to have this identifier on it, job ID equals 123. At some point in the future, we're going to get this message back, task complete. And this message is going to contain some identifier that we're going to use then to go and look up that state in our app store. That app store could be memory, it could be database, it could be file, right? But we're using that operation parameter to go and look up that state, and then we're able to complete our work, right? So this is quite common. We get some parameter, we use it to look up app state, we operate on it, do our work. There are, of course, several other mechanisms, like I said, for doing correlation. Let's step back and do a little survey of the way that we've been relating messages to each other since 3.0 and relating messages to app state. So in 3.0, we had channels, right? All the messages exchanged on a session channel were related to each other, related to a particular instance. We had a request channel, reply channel for relating requests and replies. But all of these channels were transient objects, right? When they went away, there was no getting back to the instance. You couldn't find that instance again as soon as this channel object was disposed from memory. So in 3.5, we introduced the context exchange protocol, which improved our situation a bit, right? This was a cookie-based protocol, except it worked over SOAP as well. It piggybacked on the app protocol, so we used this initial request response from the client to the server. The server would stamp some GUID in a header, send that back to the client on the first request response. The client would then attach that GUID on all subsequent requests. The server would use it to look up the state that it was supposed to operate on. In 4.0, we complete this story, introducing the ability to correlate using values in the message and giving you a unified programming model over all correlation mechanisms. The concepts around this are pretty straightforward. You define a correlation query over your message content to express how your messages are going to be related to each other, how they're going to be related to instance state, what values you're going to use from that message. Those correlation queries are evaluated on all inbound and outbound messages. The results of those queries are associated with the instance by the dispatcher, or the dispatcher is going to use the results of those queries to look up an existing instance. These associations are stored with the instance in the instance store. When we thought about all the different ways that messages can be related to each other, messages can be related to instance state, we came up with a unified programming model that works over all correlation mechanisms and allows you to define your app protocols abstractly from the mechanism that you're using. So there are two parts to this. First, we broke down all of our primitive message exchange patterns, all of our primitive protocols to work over one-way messaging activities, the send message and the receive message. The second part is we introduced a single common abstraction representing the rendezvous of these messages with other messages on other instance state. And so the way that works is you define your messages, you declare your messaging activities, and you declare a correlation handle as a workflow variable. You bind those messaging activities to a common correlation handle to indicate that they are related. Of course, higher-level exchanges are going to be modeled using these lower-level exchanges. So the service operation and the client operation that you saw in the previous examples use send message and receive message and correlation handle in their implementation. If you're familiar with the various messaging patterns that induce the need for correlation from BizTalk or other messaging experience, This correlation capability within the framework supports all of the patterns that you see in BizTalk. So the handshake protocol, sequential convoy, parallel convoy, and dummy send. Except we don't make you send a message in order to initialize a correlation. We've got an activity for you there. And finally, of course, the persistence interactions and the framework have been designed to work in a multi-node environment. So that was a lot of data. Let's try and make it more concrete to reinforce those concepts. So here we've got our application has been turned into a workflow. We've declared a correlation handle. We've got our send message, our receive message bound to that correlation handle, indicating that they're related to each other. The work starts. We've got some state, right? Job 1, 2, 3. We send a message, submit task. And over that message, we've defined a correlation query that extracts that job ID, job ID 1, 2, 3. And then we store the results of that query along with the workflow instance in the application store. At some point later, we get a task complete message over which we've defined another correlation query that's going to extract the values, job ID equals 1, 2, 3. We're going to use those values to look up our workflow instance and resume its execution and complete our work. So here's our example again. You can imagine that, as it turns out, our media service is actually operating over this vast archive of pictures that isn't online all the time, and we wanted to be able to allow people to submit requests even if the back end was offline, and we get them the results at a later point. So we've broken up that HTTP request response into one-way message exchanges using queues. And we'll go over the various correlation mechanisms that we're using to accomplish this. First, between the picture service and the picture info service, we're using context-based correlation. In the 4.0 time frame, the context protocol has been augmented to work over one-way channels, over datagram channels. So a client can attach a callback context that the server can use to reestablish context with the client. The picture service and the back-end media service are using, sorry, that would introduce some misconceptions. The media service is something that we don't control. Let's say that this is something that we can't deploy anything onto, like the context binding. So we're relying on messages in the values from the picture service perspective in order to relate messages exchanged with the media service to an instance of the workflow that we're using to define the picture service. And finally, given that this is all happening using asynchronous messaging, working over queues, it's handy if we're able to shut that client down when there's some message outstanding. And so we've got a workflow service in the client, and we're sending our picture request to the picture service and getting our picture back using context-based correlation on the client, allowing us to take the client down and bring it back up. So let's go switch over here. And now we're going to take a look at how that picture service was put together. So instead of using a service operation here, I'm using the receive message activity. I've called it get picture. Down at the bottom, I've got this get picture response. This is the sending the result back to the client. Wonderful. Using one-way messaging. The implementation of this service is still being done using parallel calls to the back end. So I've got this parallel here, and I'm making these calls to the back end over queues. Given that we're doing this over queues, we need some mechanism in order to relate the messages that are coming back to us to this particular instance. So let's go and take a look at how this is done. We're going to take a look at get picture info first. Just one comment on the contract. We're using one-way messaging, So we can't expect a fault to come back to us when we send our message. All I've done here is I've defined the possibility of a failure on my callback contract. So I've got this picture info failed here sitting in parallel with the picture info response. So this is an example of how I can be waiting for a couple of different messages and using correlation and persistence and the expressivity of workflow, I'm able to model these possibilities in a very succinct way. This parallel is configured to cancel the outstanding branch when either the response or the failure comes in. I'm using a correlation handle here. I've declared my picture info service correlation handle that I've bound to from my send message activity. So if we look at the send message activity, you can see that my correlation handle argument has been bound to that picture info service correlation handle. Sorry, that's quite a mouthful. If we look at the receive message, it's going to have the same thing. So here, I've bound to the picture info service correlation handle. And this indicates that the send message and the receive message are related to each other. As I mentioned, we're using context exchange as our binding for both of these. Both the endpoint exposed for the receive message and this send message have been configured to use context exchange. MSMQ context binding is just a binding that I made up in order to put the context channel over MSMQ. And the great thing about this is the context channel is going to contribute one of those correlation queries that I talked about. I don't have to express that because the channel has a fixed way of establishing correlation, and it's just going to contribute a correlation query that the dispatcher is then going to use and evaluate over that the messaging activity is going to use to evaluate over the outbound message and associate that message with this instance. Cool. When that message from the service comes back and says, hey, here's your response, the endpoint that is working on this for this picture info response or failure is also using the context exchange protocol. And so it's going to have contributed a query that gets evaluated. The results of that query are used to look up this particular workflow instance. Execution resumes by virtue of the action on that message and the fact that it's bound to this correlation handle. So the nice thing about context, using context there, is that I didn't have to express exactly how those things are related. I just had to bind those messaging activities to a common correlation handle. Over on Get Media, we've got a different story, right? I've declared my media service correlation handle over here, and I've configured my Get Media and my media response and media failed activities to be bound to that common correlation handle. You can see that I'm not using the context exchange binding here. And so I'm going to have to use something different to express my correlation. If we go and we look at the contract for Get Media, you can see that it takes another parameter named job ID. Job ID, I've declared this variable that's associated with this workflow instance state. I'm going to have initialized that variable to some random number between 1 and 1,000. And I'm passing it in here to my call back to the media service. And of course, I'm passing in the name to express which picture that I want. But now if I look down here, I can see that I've got this correlation query defined over the message where I'm extracting that job ID and associating that job ID with this workflow instance. If I go and I look at the response message, right, same deal. I've got job ID on the contract here. When I look at the endpoint that I've configured for this response message, one of the endpoints that I've configured, you can see that I've got, again, a correlation query defined, a different correlation query, because it's a different shaped message, but it's going to extract a value that's going to match the one that was established by the send message. Make sense? So this is pretty powerful, right? By virtue of the fact that I've got correlation, I've got persistence, I've got a broad variety of ways for expressing the flow of my services. I'm enabling a whole range of new messaging scenarios that were previously very difficult to actually code and to develop. The code for this would be somewhat complex. Given that these are all queues, I can just start my back end here. Oh, I forgot the chicken sacrifice, but we shall recover. And I can start up my client. Actually, you know what? We're using queues. So instead of that, let's actually kill our back-end services. And let's start up our client and send a request. Nothing's happening. We shut down our client. Let's start up our client again. And then we can maybe start up those back-end services and see what happens. So, sorry about that. When I start up those back-end services, they're going to get the messages that have been sent to them from the picture service hosted in Dublin, send those messages back, and then finally the picture service is going to coalesce those values and send a message back to the client. But by virtue of the fact that I had a workflow service in the client, I could bring this thing down, bring it back up, and get that response that was related to the request that I had sent in a previous instantiation of this client. So there you have an example of how correlation is facilitating the coordination of messages with app state and pushing the complexity of that coordination code into the platform. Great. Having built some services, what about hosting them? So Workflow Service Host is the thing that gives us our host for services built as workflows. Workflow Service Host is responsible for managing instance lifetime, for dispatching messages to instances of our workflow, for giving us a consistent threading environment. It's the thing that's participating in correlation. It's the thing that's going to flow transactions in for us. Workflow Service Host allows you to write extensions. We've written a variety of them. A couple I've got on the screen are for persistence and for tracking. You can also write your own host extensions that allow you to plug into messages coming in for a particular workflow and workflow events like instance idle or unhandled exception. When you're handling those events from a workflow instance, you can perform control operations on that instance. You can unload it, or let's say in an unhandled exception scenario, you could abort it, roll it back to its previously consistent state, go fix whatever was wrong, and try running it again. Further to this, as I mentioned, we expose this management endpoint, which allows you to perform control operations. You can think of this kind of like workflow instance with a service contract on it. Great, so we've got this workflow service host, but who's going to instantiate it, and who's going to manage that? And the natural default answer to that should be the Windows App Server using Dublin, which is a set of extensions to the App Server role and to IIS. So Dublin is the evolution of WAS IIS and the Windows App Server role, focused primarily on hosting, persistence, monitoring, and tracking, and some messaging capabilities. So it provides a rich set of PowerShell management APIs that operate against that management endpoint, allowing you to do things through PowerShell like cancel a bunch of workflows or an individual workflow, or restart some workflows. It also operates over those Dublin stores. Dublin extends the IIS manager, giving you instance query and control capabilities, again, using those PowerShell management APIs. It also exposes a bunch of tracking capabilities that we're going to take a look at rather soon. Dublin comes with a timer service for waking up workflows using the delay activity. It comes with an instance restart service so that if a machine or a process goes down, we're able to restart a particular workflow that was in flight. I don't mean a workflow that was idle. I mean a workflow that was in the middle of executing. Dublin has a restart service for resuscitating those workflows. Dublin also has a router in it, a content-based router that's going to be very handy for doing things like versioning, bringing new services online, deprecating old versions of your service. It's going to be available as a free download that works over Windows 2008, Windows 7, and Vista. Dan Eschner is doing a talk on Dublin. It's a fantastic talk. I'd encourage you to go see it. He's going to take you through the breadth of all of the things that Dublin is. Great. So our services are hosted. They're exposed to the outside world using Dublin. Let's take a look at how, using WF, we've increased the transparency of our services through tracking. So what I'm going to show you here is the tool that we know and love for managing our services with some extensions to it. Here you can see the Dublin extensions to IIS Manager, some for deployment, database configurations, configuring your diagnostics, looking at instances that have been persisted, configuring your individual services, configuring tracking, and setting up tracking profiles. Like I said, Dan Eschner is going to go through a bunch of all of those extensions in his talk. The thing that I want to focus on are the persisted instances and the service configuration. So here's our Get Picture service that we've had hosted all this time. This is the one-way version. And as you can see on this thing, I can configure my persistence extension. I can configure tracking. I can configure my certs, throttling, and I can also take a look at persisted instances and endpoints. The thing that I want to do is configure some tracking profiles. Tracking profiles, you can think of them as just a set of queries that I want to evaluate as my workflow runs, as my workflow service is executing. I've got the basic workflow tracking and the verbose workflow tracking set up. Basic gives me workflow level events. Verbose gives me kind of activity level events. So let's get one of our services into some funky state. Oh, sorry, did I do that again? Let's just shut down one of these things. And we'll start up our client, or we've got our client going here. We'll make a request. What kind of fruit do you guys like? How about lime? Do you guys like lime? Okay. So, great. I've got my request out there. Nothing's happening. What's going on? Well, let's go and take a look at our persisted service instances. You can see here that I've got an instance of my picture service. It's in the blocked state, which just means that it's waiting from some external input to resuscitate it. On my persisted instance, I can perform various control operations, suspend it, resume it, terminate, so on. These are just this is just UI over those PowerShell commandlets that I was talking about earlier that are interacting with the management endpoint. So if we look at the tracking data that we've generated for this thing, we kind of see some, you can think of this kind of like flight recorder information for your services. So you can see that we've got a bunch of tracking events that we've recorded. Cool. And if you look at the activities that have been scheduled and have been closed, you get some insight into what's going on in your service. Here we've scheduled our media response. And down here you can see that our media response activity was closed. Okay? Here we scheduled our picture info callback and our picture info response. Sorry, the callback is the name for the parallel. But our picture info response and our picture info failed. But wait a minute, I don't see any corresponding closed record for this thing. So I know what happened. We've got one of our back-end services are down. Let's start that up. And now you can see on our client that the message got back to the picture info service and the service completed. If you look at our tracking information, we run this query again, you can see that indeed the picture info response was closed, that other branch was canceled. If we look down here, you can see that in fact the workflow itself has been completed, and that makes a lot of sense because of the result that we got back at the client, right? So here you can see that the workflow completed. So this is pretty cool. I express my services as workflow, and I get them to be self-describing for free through tracking profiles, and the tool that I'm used to using for managing services is the tool in which I can do all of these instance control, instance query, and queries on my tracking information. So a common question that we get at this point is, great, when should I use workflow services? Consider workflow services if your services are doing some kind of asynchronous work, right? Calling a database, calling a service, touching the file system. All of these things do async I/O. Workflow pushes the complexity of coordinating that async code into the framework, and you'll have a much simpler service to offer and maintain, giving you those performance characteristics that you're really after. If you've got a service that performs parallel work, consider using workflow services. It's very easy to express that work using workflow. If you've got a service that checks and makes sure that a particular message has arrived before another message, or that certain messages have not been sent, expressing that logic using workflow is a very natural thing to do, right? Just even consider sequential enforcement. If you put a bunch of receive activities in a sequence, the runtime is the thing that's going to enforce the sequence of those messaging activities for you, and will reject invalid messages. If your service does some kind of coordination between messages and app state, needs some kind of correlation, you've seen how workflow can facilitate that for you. Of course, if your service is long running, needs to be persisted and resuscitated, workflow's got the facilities for that. And finally, if you want your services to be self-describing and to get that tracking information for free, implementing your services using workflow is a natural way to get that. We've made a number of improvements to WCF independent of our investments in workflow. So let's go through a representative list here. The REST toolkit is out. Cool. All of your concerns around HTTP, using HTTP with WCF for security, for caching, for error handling, all of that stuff's being made easier with the REST toolkit. The REST toolkit also provides a bunch of templates for common REST scenarios: Atom pubs, singleton collection, simple feed. The incomparable, the incredible Steve Main is going to be talking about REST tomorrow. I'd encourage you to go see his talk. Your understanding of REST and the way that our bits address those scenarios will certainly flourish under his tutelage. Discovery, another wonderful thing that we've shipped in 4.0. All you need to do to make your services discoverable by the WS Discovery protocol is add an endpoint, the discovery endpoint, and add the discovery behavior to your services, and we will start responding to WS Discovery messages on your behalf. If you want to look for services that match a particular criteria using WS Discovery, we've got a discovery client that will allow you to resolve those endpoint references. We've got a few new channels in the 4.0 timeframe, UDP for your low latency scenarios, and for when you're trying to do duplex from behind a firewall or a NAT, we've got the HTTP polling duplex that's going to be put into the 4.0 framework. We're turning the crank on standards for a couple of them. We've also noticed that people want to be able to repackage or reuse endpoint configurations. So my configurations is probably confusing, just endpoints, right? So, kind of like bindings. When you wanted to be able to reuse a stack of channels, you would write a new binding and then pass that around. People could reuse your setup of that particular stack of channels. Well, with endpoints, we allow you to enforce some rules, provide some behaviors that are going to be consistent on your endpoint, and maybe do some smart defaulting in terms of the bindings that you want to have, so you can package up your reusable endpoint and use that to configure a service host. I've already talked about the extensions that we've made to Context Exchange, giving us durable duplex, the ability for a client to attach a callback context and have that flow to the service, and the service to reestablish context with the client. And finally, we've heard some of you are having fun in config. You'd like to spend less time using the config system. So, to that end, we're taking a step back and looking at the problems with config, the fact that it's cumbersome in some areas, the fact that the defaults aren't always exactly what you would hope they would be. And we're going to be providing capabilities to give you default config, eliminating the need for config at all in a variety of scenarios. So we're going to make some significant investments in config in the 4.0 timeframe. So to sum up, workflow gives you the ability to coordinate work and push that complex coordination code into the platform while increasing the transparency of your services. As we have more and more distributed work, as we are getting our work done more and more in a piecemeal fashion, applying a runtime that commoditizes complex coordination code and pushes it to the framework gives you greater productivity and greater quality of your services. Specifically, we're giving you some new things in 4.0, specifically around asynchronous coordination, rainy day scenarios, and relating messages to app state. By adopting WF as the authoring model for your services, you immediately increase the transparency of your services. They become self-describing. Dublin, extensions to the app server role and to IIS, provides enterprise persistence and tracking and management capabilities and much, much more that makes it the premier, the perfect host for your WCF and WF services. As I said, I'd encourage you to go and attend Dan Eschner's talk this afternoon to hear all about Dublin. There's a list of sessions that are related to workflow services in a variety of different ways. We've just gone a few minutes over. So I'd love to open up the floor to questions at this point and invite Kenny Wolf up, the architect of much of this stuff, to help me answer some of those questions. Thanks very much for coming. If you want to ask questions, I'd encourage you to go to the mics so we can record some of this stuff. So it looks like we have a question over here in the middle row.
Oh, okay. If you have 1,000 workflow programs defined, and all of them are have persistence set up, are they sharing the same persistence service, or are they all have their own individual copies, and we have polling 1,000 instances polling the database?
So the way that persistence works is the host is responsible for loading a workflow in response to some input. And so as input comes in for those instances, the host will do the loading. So you can imagine a message in a workflow service host, right? Coming in, the host is going to do the thing, is going to make the async call to the store through the persistence extension and load that thing up and resume execution. So we're not doing any polling. It's in response to some input that's arrived.
Well, I'm referencing if you have a delay and you need to have the workflow wake up and go communicate to some other system.
So again, all communication is being normalized through messaging for these infrastructure services. Mm-hmm. So again, if the timer service happens to be sending a message through the infrastructure as opposed to an app sending a message, right? The delayed activation, the correlation, the persistence happens on an on-demand basis based on the incoming message. Okay, so there's no polling of the database in any of those cases.
Okay.
Does that help?
Unlike with the current workflow system.
Exactly. Yes.
Okay.
That is a key difference from 3.0 and 4.0. Yes, absolutely.
Right. And one more question. On the flow chart, can you arbitrarily set which activity is executing from the host? Like the state machine, you can configure it to move to a different state?
We can follow up on that offline.
Okay.
Yeah, so far right now, again, the workflow controls the control flow logic, right? And as far as adjusting the workflow on the fly, right, there are facilities for that, depending on what the case of your workflow is. I showed some of that with dynamic update.
Yeah.
But it depends on your particular situation. Let's follow up offline.
Okay, thank you.
We're supposed to be round robining here, so let's go to the right.
I do a lot of work with BizTalk Server, and so I'm wondering, Workflow 4.0, WCF 4.0 plus Dublin, why do I still need BizTalk?
So BizTalk continues to be our premier server for integrating with other applications through the adapters. And sorry, go ahead.
They're all WCF now. All the new adapters through the BizTalk adapter pack, they're just WCF channels into SAP, Siebel, Oracle.
Yeah, so the other thing that BizTalk is providing, though, is the ability to configure the receiving of those messages over the adapter and the underlying delivery of those messages to orchestrations. So there's the decoupling of the EA, of the enterprise application integration that is still a BizTalk feature. From a framework perspective, we don't have that, the ability to configure that kind of rich decoupling from receive ports through orchestrations, through workflows, through send ports. That said, this is obviously a long-term design point that's still on the horizon for us. Go ahead.
I'm developing SharePoint for 2 years now, and I'm frustrated sometimes because there's another implementation of the workflow foundation in there. Will this be the same in future, so we have one common WCF 4.0?
So yes, the short version is yes. Given that, as you know, we deliver different products on different time frames, we are targeting a post-Office 14 version for that upgrade. You'll see Office 14 and 4.0. We would have had to have 4.0 done pretty much by now for Office 14 to have been able to adopt it. So you'll see Office 14 on top of .NET 3.5. That's not just workflow, that's across the board, right? And in a future version, post-Office 14, we're already started investigations. We've done some initial prototyping, and you'll see some deep, deep integration between the 4.0 system and the SharePoint system all up, including WF, WCF, Dublin, the whole meal deal. Absolutely.
Go ahead.
I have almost the same doubt. You see, the WF is a framework and it's built for to build hosts based on it. So for us that use Microsoft as a technology provider, we are most interested in servers, your servers based on your framework. So here we are, SharePoint, BizTalk, and TFS, and so on. So my question is, if you go to the Microsoft.com/BPM, there is a guidance how to adopt BPM from Microsoft. And in your presentation, you showed some issues, some questions, some points that are more fitable to SharePoint or even BizTalk, like tracking versus business activity monitoring or orchestration. The kind of the example you gave is more suitable to an orchestration running under BizTalk by considering best practice. So my question is, what is the roadmap to adopting WF4 and WCF using doubling, considering this high level of abstraction? Because you see, unless I'm ISV that releases horizontal products, competitors from BizTalk and SharePoint, this level of abstraction is too low. And if you go comparing Microsoft with other players like IBM and Oracle, they offer us a high level of abstraction, and this is the kind of stuff we'd like to go to see here for the next few years. So the question that my fellow just issued is almost the same pain I have. How Microsoft is going to serve us a high level of abstraction to implement BIM, SOA, and BPN and SOA solutions on top of his products. Okay, its products. Did I make myself clear?
Yeah. So I mean, you're expressing a common concern around having a disparate delivery of framework and server products, and if I understand your question correctly, is when are these things going to align?
Yeah, and I'm not going to build this kind of web services. I'd like to do this in an orchestration inside BizTalk with pure web services running in your ISV.
Okay. It sounds. I'm personally looking. We should
follow up. I'm talking generally.
Sorry. We should follow up on most of this afterwards. The short version is that again we have a long-term plan to build on shared technology. Right. Some of what you see are point-in-time developments. Okay. Obviously, there's a lot of synergy among the SharePoint scenarios, the BizTalk scenarios, the TFS scenarios. Okay. TFS is on a plan to align actually in the 4.0 timeframe, since we happen to be in the same box, building on top of workflow, giving you a rich server there. BizTalk is not set to align in the 2009 timeframe, but post that, we're looking at ways for deep integration. Same thing with SharePoint post Office 14. So again, you'll see this product adopted broadly, but one of the things to remember and consider, right, is Windows Server is a platform for hosting these things. Windows Server will include Dublin. Right, what you might see in the Windows 7 timeframe is a download-style solution. Dublin, think of it as part of Windows Server.
Yeah. Okay.
And we need to let other people ask questions.
So are you going to give us more instructions in your site /BPM and so on to?
We will absolutely capture that feedback and make sure that where guidance is needed.
That's my point.
We'll be putting it up there. Thank you. Did we have one over here? No questions over here? We've got a question over here.
Hi, I am using WCF, NWF, using your message queue binding for one-way. It's the only binding I am aware of that is disconnected and durable on the messages. But message queues has a 4 meg limit that we are having a hard time to get around that limitation. You wrote a program that downloads images. If the image was bigger than 4 meg, what would you do?
There are a couple of things. There are a couple of ways that I could think about that. One would be to adopt a chunking protocol.
It doesn't work very well. We tried it. It works 97% of the times.
So are you talking about it working 90% of the times because of the lack of coordination protocols between MSMQ and WF? Because those things are getting much better in the 4.0 timeframe, right? The ability to flow transactions and the ability to actually have a much richer consistency between the workflow state and MSMQ is something that we've invested heavily in 4.0. Another alternative approach that I might use is to, instead of passing the image itself around, to pass a pointer to the image.
Yes, we did all these things. I'm just wondering, a limit like 4 megs those days are very restricting. There is another queuing system in SQL Server that allows you to do the same thing. Are you planning to add an endpoint support, a binding support for SQL Server queuing?
Okay. So I've been informed you should go talk to the message queue people we have at the lounge. There have been some updates to handle large messages. So they can give you the details in the lounge, but it sounds like good news.
Thank you very much. What's the name, or is there a name I should ask?
Just come talk to Dana up front.
Excellent. Thank you very much.
Go ahead.
A batch process, a workflow that's long running, and we have exposed it through WCF. So we are able to start the workflow and all that fine. But if we had hosted in a normal console application, we can say suspend. We can get the workflow instance, call suspend, resume, and all that. But when we go through WCF, we don't have that flexibility. So have you addressed that in WF4? And for WF 3.5, what do you suggest?
So we definitely addressed that with the management endpoint that I brought up. In the 4.0 timeframe, you're able to use messaging in order to control individual workflow instances. For 3.5, the best thing that I can suggest is by extending WCF, writing an extension to your host in order to manage instance interactions. The thing you'll need to be careful about is obviously the synchronization of incoming control messages and your instance interactions, and trading off the complexity of coordinating individual instance interactions with a flood of messages coming in. So it depends on your throughput needs and the characteristics of your service. But the way that I'd approach it is I'd write a host extension to the workflow service host, and from there perform control operations on the workflow instance.
Okay. I have a quick another question. Mm-hmm. Multi-threading, well, all the workflows run in a single thread, right? But there are some of our batch processes that need to be really performant, and I want to know if we can use multi-threading within an activity, right? Or roll around implementation of multi-threading within an activity. Is it okay to do that?
You should come to Matt's talk this afternoon on extending activities. He'll show you exactly how to do that type of behavior.
Matt's what talk?
Matt's talk on extending custom activities in WF 4.0. It's this afternoon, and he will go into not just that we can do it, but how we do it.
Yeah, there's also a chalk talk today. I forget when Nate's talk is. I think it's.
But if you stop by the lounge as well, but go to Matt's talk. He'll cover it in graphic, large screen details.
Cool. Thank you.
And we've got a. We're getting the cut, so we'll be outside. We can answer questions there.
Actually, we're going to go down to the lounge and hang out there. So if you've got more questions, please find us in the lounge. Be happy to talk to you. Thanks for coming.